Okay, good morning, everybody, and thank you for joining us this morning for what's the final session, session 4 of the Flat Roof Surveying Comprehensive Guide. So I've done the other 3 sessions. Thank you to all of those that have attended all 4 sessions. If you have missed any of these sessions, they are available on our YouTube channel. If you just search for Cookson's Consultancy on YouTube, you'll be able to find the other 3 sessions. But for now, we'll crack on with this one. So, like I said, this is the final one, and this is flat roof interfaces and best practice detailing. So let's see if we can move on here. There we go. Okay, so over the last 3 sessions, we've covered those top 2 things. We've also covered quite a few of the others, but we're just going to circle back now and go over those last few things there that you can see. So the height of upstands, existing drainage, condition of roof lights, those kinds of things. And we're just going to have a look at kind of what best practice detailing looks like when it comes to those. So when I survey a roof, when I'm on there walking around, I've got one eye on the current defects, and then I've also got one eye on what best practice detailing should look like, and also what solution I'm going to put forward for that. So what kind of upstand heights can we achieve if we bring the roof up to current building regulations and things like that. So if we're going to add any thermal insulation on there, if we're going to do a thermal upgrade, have we got room to do that with the detailing that's there already? And can we achieve best practice of kind of 150 mil for upstands and things like that? So that's kind of what we're going to go through. That's kind of like I say, when I survey a roof, I've always got one eye on that and what we're going to put forward. So to achieve this now, we're going to have a look at what the most common roof termination details are when it comes to a flat roof. I'd say most flat roofs have got some of these termination details on there. Obviously, you do get the outliers where there's something bespoke that you need to put together, something that you come across. But like I say, 9 out of 10 kind of flat roofs have got some, or if not all, of these details on there. So first, we're going to start with upstands and kerbs. BS 6229. Which is kind of like the Bible, I guess, for flat roofing British standards. That generally says that 150 millimeters is required above the finished level of waterproofing. So the finished level is quite important there, because like I said, if you're going to do a thermal upgrade, let's say you've already got like 50 millimeters of insulation on there, you need to put another around 100 millimeters on there to achieve your 0.18 U value. If you're bringing the roof up to thermal values, you need to have a look and make sure that all of those upstands around there can incorporate that extra 100 millimeters, and we still then can achieve 150 millimeters further on top of that. So it's worth, obviously you need to be measuring your upstands, looking at roof light curbs, seeing if the roof lights need replacing, seeing if glazing, door thresholds, those kind of things need to be raised. When it says door thresholds in BS 6229, they can be around 75 millimeters high. And like it says there, exposed edges of the waterproofing should be protected with like a flashing or a cover strip or something like that, so we're not leaving the waterproofing, we're not bonding it to an upstand and then leaving it exposed so water can get down the back. So flashing details and things like that we'll have a look at. So on this particular one that we're going to just have a look at here, this is a roof light detail. But this could be an upstand detail. It could be a brickwork upstand with a chase. It could be any kind of upstand detail. So let me grab my pointer. So you can see there we've got the 150 millimeters for a start above the finished level of the waterproofing. So this is your waterproofing layer. This is your insulation. This is your vapor control layer, and this is your screed. Important thing here as well when it comes to any kind of upstand is that the vapor control layer meets up with the waterproofing at this kind of this level here, which stops any kind of cold bridging coming through into the insulation. So we need to have that vapor control layer fully encapsulating the insulation, and that can either be achieved by taking the vapor control layer up the upstand and then bringing the waterproofing onto it, or in other cases the vapor control layer can be folded back along the insulation there, and then the waterproofing taken over the top. But this junction here is a critical junction to stop any air and vapor getting into the system there. Obviously you've got your deck and everything here, but that kind of gives you the idea of that 150 millimeter upstand there. Just going to have a quick look at that. This diagram here is taken from BS 6229, which I think in turn is taken from the NFRC guidance. But you can see again here you've got a door threshold in this instance, and you've got this 75 millimeter upstand, and this is your finished level of waterproofing. In this instance, we've got a flush access detail. So we've got paving slabs or whatever it might be on here, paving slabs, timber decking, whatever that might be on your terrace or your balcony. So you've got flush access here for anything like wheelchairs and push chairs and things like that might need flush access. Important again is this, which is the fall, is that the fall is going away from the threshold. We don't want the fall going towards the threshold when we've got, we don't want falls going towards any kind of upstands really. It's quite important that falls go away from the upstands if we can. On a flush access detail, we need to make sure that these, again, these gaps between the paving slabs, this is different in this instance. So we've got a gap of 4 to 8 millimeters between the paving slabs, and then you need a minimum gap here of 10 millimeters for water to drain down here, or you might have a channel drain or something in this instance. But like we say, the critical thing here is that we've got that 75 millimeter upstand. So when we're surveying the roof, we're measuring this, we know what kind of rough thickness of insulation we're going to need to achieve our thermal upgrade, and then we need, on top of that, we need to know that have we got this 75 millimeters. If not, do we need a new door threshold? Does the door threshold need raising? Same with kind of sill details and things like that. Do these details need raising? And then at the back of here, you can see this number 6 again is that's your 150 millimeter upstand here. So that again above the finished level. So in this instance, we're not the finished level of waterproofing, we're above the finished level of the roof. And in this instance, the finished level is the paving slabs. So we need 150 millimeters above there. So we'll have a look at a few pictures now of some surveys, good practice, bad practice we've got in this presentation, as we like to show it. So in this instance, we've got a door threshold here. We've got asphalt waterproofing, which is coming away from the upstand here. The asphalt has started to slump over time, and that measurement there is circa 110 millimeters. To the door threshold here, it's probably a bit less. You're probably looking at about 90, 100 millimeters. So if we were to thermally upgrade this roof, we'd need to be thinking, we'd need to have done a core sample, obviously, to find out to establish what the existing thickness is, and is that insulation in good condition, so that we can put more insulation on top, or does it need stripping back to the deck, and do we need something around 130 millimeter thick insulation? So then, does this door then need replacing? That would tell us within our survey. If the door can't be replaced, if the threshold can't be raised, all those kinds of things, then all of those things need to be raised with the manufacturer who's putting the specification together, because it's up to them then whether they will guarantee this door threshold here, or whether they'll exclude that from the guarantee and maybe put in that it's a maintenance item and needs to be checked every 12 months or something like that. We can see as well in this instance, we've got a bit of ponding water here, so we might need to do something to adjust the falls on this roof and get this water to be falling away from the upstand. So all things we need to be considering when we're surveying the roof. We do need to be a little bit pragmatic sometimes as well when it comes to surveys. So this is a single ply membrane, still in fairly good condition. So we're doing a condition survey on this roof. But because usually when we get called to a roof, we're doing a condition survey because there is water ingress. So we need to determine what the level of water ingress, does the roof need stripping off? And if it doesn't, can some localized repairs be carried out? Or can we put maybe a liquid overlay over the top of this, or perhaps another layer of single ply or something like that? So in this instance, the important thing is we've got 110 millimeters. Now, this is a big bank of windows in this instance. So do we really want to be saying, okay, we're going to put a liquid over this, for instance, but we need to take all of these windows out because we need to achieve another 40 millimeters of upstand here. There's no ponding water. The falls are going away from the windowsill. So we need to be a little bit pragmatic and say, okay, do we accept 110, 115 millimeters as an upstand in this instance? And again, that would be down to the manufacturer. But if it was me, having worked in the technical department for many manufacturers, I'd be saying that in this instance, it's probably okay. It's 115 millimeters. We don't need to exclude that from the guarantee. It's going to be okay in this instance. So again, a bit of pragmatism. When we say about protection of exposed edges when it comes to waterproofing, so obviously this access hatch has been retrofitted, but there's been no consideration given to really, is this going to be long-term watertight? They've retrofitted this to a curb, mechanically fixed it here. These screws that they've mechanically fixed it have probably something to be desired. Is that going to stay in place? But anyway, the important thing is here, in this instance, the mechanical fixings, of course, should be adequate, but they should be taking the waterproofing up to finish underneath this protected lip here, because this mastic seal here is just going to fail over time, and then water is eventually going to get ingress into here. So there should be the membrane should be finished underneath here, and like I say, protected by this preformed kind of flashing that's on the roof light. Again, upstand heights. So we're looking at, again, this upstand height is probably below the 150 millimeters. So your 150 millimeters is here, but in this instance, we've got a cavity tray. So are we going to have to remove this cavity tray in order to achieve more? No. We've got 100, again, we've got about around 110 mil. But the key thing in this instance is this single ply has not been terminated correctly. So any kind of wind-driven rain can fall against this brickwork here, run down behind the single ply waterproofing system. This waterproofing should have been taken into the chase and wedged, and then a flashing should have been put over the top, a lead flashing or a preformed metal flashing, a single ply kind of flashing that comes with the systems, something like this. So we've got good practice in this instance. So in this instance, again, you've got your single ply membrane. That's what the previous one should look like. The waterproofing taken up, that waterproofing is taken into the chase, and then the chase into the chase then is a flashing which protects the top of the waterproofing again. So any water that's running down here is hitting this flashing and coming over the top. Same with a liquid. So this liquid again has been chased into the brickwork. Nice neat job, and then a mortar has been put into there. So in this instance, there hasn't been a flashing over the top, but the manufacturer is probably happy with that because it looks like a nice, neat detail anyway. Like I say, the waterproofing has been taken into that chase. What should that roof light have looked like? Well, this is kind of what we were saying. So the waterproofing goes up and underneath, and it finishes underneath that flashing detail, that preformed kind of capping over the top there. So it's got some protection. Felt detail, like I said, up, but take the felt up there, separate detailing sheet. So your cap sheet is going into the the roof light here, and then you've got your separate kind of, you've got your underlay underneath here, and then you've got your flashing piece that goes over the top and is finished underneath there, and that exposed edge there is protected by the capping detail on that roof light. So drainage details on flat roofs. Flat roofs usually discharge to one of those kind of types of outlets there: internal in gutters, external kind of welted drip details into half round gutters. So you can see kind of a myriad of different ways of draining a flat roof. The recommended minimum finished fall for drainage on a flat roof is 1 in 80. So BS 6229 again says a design fall of 1 in 40 with a finished fall of 1 in 80. And the waterproofing should be taken into the throat of the outlet. A liquid can be taken into the throat of the outlet and should be down a minimum 50 millimeters, and must always finish on a downward facing edge, again to stop that, to make sure that edge is protected, finishing on a downward facing edge. And a membrane again should be taken into the throat of the outlet and additionally clamped with like a clamping ring or something like that. So in this instance, we've not clamped the waterproofing or anything like that. So this felt has been bonded over the top and then has just been cut around here. This is a common kind of failure point around outlets. In the previous sessions, we showed that waterproofing notoriously kind of comes away at these details. So water can track underneath the waterproofing and down the outside of the downpipe. Like I say, it's always worth kind of checking these. If there's outlet covers on there, it's always worth taking them off if you can. And just checking the waterproofing around the downpipes. So like I said, good practice with a liquid. So this is a steel outlet here that they're preparing with a wire brush, taking all of that rust and corrosion off. This will be the primer that's going on, metal primer, and then the liquid waterproofing then taken down, finished on the downward facing edge. Really good practice there. Nice, neat job when it comes to a liquid system there. With the membrane system, so on the left-hand side there, you've got a single ply system. This is a single ply refurbishment outlet. So you can see the bowl here, and then so the waterproofing would be taken into here, and then this clamping ring then would be mechanically fixed into there, and then the outlet again would be mechanically fixed over the top. So that forms a nice, again in this instance here, you've got the membrane coming down, and then this clamping ring or clamping collar, as it said here, is mechanically fixed down into here, which makes a tight seal and stops any water getting back underneath the system in those areas. So another form of drainage on a flat roof is a welted drip to half round gutters, or a drip detail. Welted drip, when it comes to kind of felt details, is what we call it. In these will be preformed drip detail when it comes to liquid. So this is usually a GRP edge trim that's mechanically fixed at the top edge, and then the waterproofing is taken, when it comes to liquids, taken up and finished on the downward facing edge on this face of the edge trim, for the water to then fall off and into the half round gutter. This is what a felt system would look like, and this is an old drawing, obviously, because you've got your type 3G felt. This is a pour and roll system on here, but the important thing here is that you've got your welted drip, and you've got your hardboard former. So this is how it would be done these days with a torch on system, fascia detail, and then like I say, you've got your hardboard former, and then your underlay and cap sheet will be taken around the former, and then the water can fall off the top and into the half round gutter on your felt system. Single ply system, welted drip, again, it's usually a preformed detail metal usually that the single ply can then be welded to and terminated on these sections. And then it can the single ply then can be welded and the drip detail can be formed. Okay, so we're going to have a look at a few different types of roof lights in this one. So we're looking at the type, age and condition of roof lights on this. A few different types of roof lights that we might find when we do this. We'll explore the termination details on this as well. So like I say, the felt has been taken up here, but we need to measure these upstands because obviously they look a bit low. This is a GRP roof light. You can see the fibres in there. Single skin. This will be a fragile unit and needs to be replaced. Georgian wired glass roof lights we still see, even though they're from around the 1970s. We still see these when we're surveying, particularly schools and hospitals and things like that. We see these kinds of roof lights, usually cracked. But again, looking at the upstand details, measuring these upstands and making sure that we've got good height. Again, this roof light would probably need to be replaced, and then this kerb can either be over-sleeved or built up to accommodate a new roof light. PVC, again, something that we don't tend to come across these days. Used in the 70s to the 90s, and these can usually be identified because they've usually become sunburnt these days and blackened around the edges. Acrylic roof lights, usually you can tell these by they tend to yellow over time. They are thermoformable, as in polycarbonate, which is the modern day most popular roof light that we come across, but you still see these acrylic ones, usually yellow, on schools and hospitals. And again, these would need to be replaced, so you'd need to be looking at the upstands and things like that to make sure that we can get that 150 millimeters. And polycarbonate, very common these days for domes and pyramids, those kinds of things. Obviously with different grades, we need to be looking at the manufacturer's declaration of performance and things like that. And does the roof light achieve this British standard? Like I say, different grades, different things like that. Make sure the UV protection is there. These have got high impact resistance. But the key thing is here, like when we're surveying roofs, and if we come across a polycarbonate roof light, does it need replacing? Is it that old? Is the upstand height 150 millimeters, as it probably is in this instance? So in these instances, a lot of the time, or some of the time, as long as they're not too old, these polycarbonate roof lights will last the test of time. Okay, so another termination detail we're looking at now is the perimeter of the roof. So we're going to have a look at parapet walls. We've already looked at drip details, but we're going to have a look at a water check as well on a flat roof. Parapet walls are quite important, really, if you come across a parapet. The key thing is how the waterproofing currently terminates. So is it the 150 millimeter upstand height? Again, is applicable when it comes to a parapet wall. It's usually a continuation of a cavity wall, so it's important then that we address what the top of the wall is taken into consideration when we're looking at remediation and things like that. What's the top of the wall? Is it a coping stone? Is it a metal capping? Is there a cavity closer there? Can water get down into the cavity? And like it says here, there may also be a cavity tray and weep holes that we saw. So we need to make sure that we have a look at those and make sure that we're not blocking off those weep holes. So the weep holes will be at this level. Obviously, if this is a concrete coping stone, concrete is porous, and over time water can get down into here. The mortar joints and things like that can degrade. Water can get down into here. So water hits the cavity tray, comes out here, and out of the weep holes and then down onto the flat roof deck, which is usually kind of at this level. So when we're waterproofing a system, if we're going to be thermally upgrading, if our waterproofing is going to be going over the top of here, then obviously we're going to be blocking off those those weep holes. So then any water that gets into here will go down behind our waterproofing system. So it's a very important consideration. So one way to get around it is to make this cavity tray redundant. And the way of doing that is if the parapet wall isn't too high, we can take this coping stone off. Obviously we need to look at the heritage of the building. Is it a grade 2 listed building? All of those kind of things. But can these coping stones be removed? If they can, then we can take the waterproofing. We can put a cavity closer on here, get rid of this coping stone and take the waterproofing up and over here, and then finish it on a drip or a check or something like that with a trim on this outside edge. And then what we've done here is we've waterproofed straight across here, and we've made this cavity tray redundant. So then it doesn't matter then if we're blocking up these weep holes. Let's have a look at a few examples of parapet walls. So again, in this instance, it may be that this parapet is a bit too high to be taking the waterproofing up. Obviously, if we waterproof this whole wall as well as waterproofing the roof as well, we're going to be adding a fair few square meters to the roof. It might be that that's best practice. It might be that the client has got the budget to do that. And in my opinion, it is always best practice to take the waterproofing up and over if we can get rid of these coping stones. Because as you can see, what happens over time is the bedding mortar will start to erode. These mortar joints are always an issue when it comes to concrete coping stones. You need to be looking at that. So if we can get rid of them and take the waterproofing up and over the top, that's my favoured detail. The other thing we need to be looking at as well. So one thing that we can't see in this instance is any weep holes. But what we can see here, if we zoom in, is we can see that there is a DPC that probably bridges that cavity. So that's probably why we haven't got any weep holes here. But what that does mean is water is sitting. So any water that's coming through these cracks or joints is sitting on this DPC here. And then obviously that through freeze thaw, easy for me to say, the mortar, the bedding mortar then might start to crack and everything. And obviously then the concrete coping stones are going to become loose and could become a health and safety risk as well. So we've done weep holes, we've had a look at this. This is the same detail as before, so we know what weep holes look like. They don't always have this plastic weep hole kind of thing in there. Sometimes it's just a hole in the perp end of the brickwork. Sometimes it's sealed down to here, and there's just like a little plastic tube, for the want of a better description here. But it's always worth looking at this, not only on the inside of the building as well. If you can see on the outside of the building, if you can look up and see the face and see if there's any kind of evidence of water running down the outside in these kinds of levels as well, then that will say that you've got cavity trays in there as well. Important. Like I said, an example of a metal cap in there that you might see on a roof. Single ply here, the single plies come away from the upstand here, and it's also important to have a look at, when it comes to metal cappings, important to look at the joints and the fixings and make sure that all of that is not contributing to any kind of water ingress as well. So back to the detail again. Like I said, you've got your 150mm upstand in this instance. What they've done here is taken the waterproofing up and over, finished. So made this any cavity trays in here are now redundant. This might be a plywood cavity closer that's been mechanically fixed into the blockwork and the brickwork. Again, we've got that interface there of the vapor control layer and the waterproofing that's important. Waterproofing taken up and over the top, and then we've got a capping on here, which might be a metal capping a coping stone or whatever goes on top of here, or not. We might not, like I said, we might not have anything over the top. We might just finish this waterproofing here into a trim or something like that on the downward facing edge, which would look something like that. And that takes us nicely now on to water checks. So the third detail that we looked at is a water check curb. So a water check must be a minimum 50 millimeters above the finished level of waterproofing. And all a water check does is stop water from discharging off the roof at those perimeter details. So again, when we're thermally upgrading roofs and things like that, we need to make sure that we're putting water checks in there. So that was obviously, that's your example in liquids. It might not be a vertical water check. We might put a fillet in there. But yeah, the key thing is that this dimension is 50 millimeters. Again, when it comes to felt, they've done a welted detail on here, put a welt on for the water check, which is quite common. And again, this dimension needs to be 50 millimeters. And that's your single ply detail, which say the usually preformed trim details, where the single ply would then get welded onto the top of that, and you've got your 50 millimeter water check on there. See, I have got some questions coming in, but what I'll do at the end is I'll circle back and we'll address those questions at the end. So if you have got any questions, just pop them in the chat there. So now we come on to penetrations. So roof penetrations fall under the 150 millimeter guidance in BS 6229. So the waterproofing is taken onto the penetration and finishes a minimum 150 millimeters above the level of waterproofing, and the penetration must be terminated correctly. So like I say, when it comes to pipes, other kinds of penetrations, handrails, everything like that, two things you've got to remember: the waterproofing should be 150 millimeters above, and the penetration should be sealed to make sure that no water gets down behind the waterproofing. So a couple of examples of bad practice here. We've got a sloping roof. This flue penetration here has obviously been put through at a later stage. It's a retrofitted flue detail, and what the installers have done. The trouble is the people that put these penetrations through the flat roofs usually aren't roofers, so they do what they think is best, rather than employing a roofer to make the penetration good once they've put it through. So flash band is one of the favorites here. Obviously this is water's running down this way, so any kind of water that sits on here over time is going to delaminate this flash band. And then obviously you've got this flange detail here, and again you've got that exposed detail there, so any waterproofing there. So what should have happened really is the waterproofing should be taken onto the flange and then finished underneath this collar detail here, where it would be well terminated and it will be well protected, so that roof is likely to remain watertight. Same thing again, penetration through a single ply roof, and they've obviously had some issues with it. They've put some mastic around there to try and stop that, but what should have happened when the single ply was installed, it looks like this was the single ply was installed perhaps after this penetration, because you've got this flange detail for the single ply here. Why they've not taken it onto this detail here and then finished it with tied it on to that penetration there, I don't know, but obviously that's caused issues down the line. Like I said, flash band is your favourite. Liquid. So liquid in this instance, liquid hasn't worked, so they've put flash band over there. Yeah, like I say, they should really be. You have got other details here where they have probably when the single ply was installed, they've done it correctly. In these instances, looks like this pipe has been replaced or something. And then again, they've not done that correctly. So what should good practice look like for a pipe penetration? In a liquid situation, you can see this one on the right here, you've got your pipe penetration, you've got your liquid taken all the way up, and it's protected then by this pipe coming down over the top, excuse me, on a smaller diameter. A cable tie can be used just to protect the top of that. Jubilee clip cable ties, those kinds of things can always be used just to protect the exposed edge of the waterproofing. But again, that's something that needs to be checked as part of your annual inspections that you should be doing. Again, felt detail, just having a quick look at that detail there on the right hand side. So the felt should be taken up and then protected by this kind of witch's hat detail here, so that nothing's getting behind. A cable tie has been installed in this instance as well, just to make sure, just for a belt and braces approach really, I think. Okay, lastly, we're going to look at plant, mechanical equipment, that kind of stuff, which is a surveyor's worst nightmare. Obviously, plant and things like that. It's a great place to put it on a flat roof, but always causes some kind of headache. And in my experience, when they install this plant, when the waterproofing is installed, they don't give any consideration for what's going to happen when the roof is refurbished in a few years' time or 20 years' time or whatever that is. So you get things like this happening. So obviously this plant was installed at the same time as the single ply system. They've done a great job. They've made sure that the termination details are done. The cable penetrations are nice. They're going into these boxes and everything like that. But what's going to happen now when we need to come along and refurbish this roof? So we've got to look at ways of jacking these pipes up and trying to get something underneath here, or the plant needs to be decommissioned and removed, which is obviously the best way of doing it, but not always possible. It's not always possible on like live buildings to decommission the plant and turn the air conditioning off and all the machines and the M&E equipment that's connected to there. So we have to look at ways of waterproofing this. So is it possible to jack it up a bit, get some waterproofing underneath, or is it do we have to look at a bespoke detail of boxing in these pipes? But obviously then we've got to consider that the pipes are going to need maintenance and things like that, so we need to give access to them. So yeah, it's a bit of a headache when you come into putting a solution together. These are good, great idea, big foot systems and things like that, because what can happen here is these legs can be locally lifted, so you can lift one or two of the legs, obviously support the system first and then lift a couple of the legs, get the waterproofing underneath, and do things like that. A lot easier. And obviously you've got access underneath here if you wanted to apply a coating or something like that. You've got access underneath here. So these for me are really, really good systems, these kind of big foot type systems. Okay, guys, thank you for your time. Like I say, that brings the this session to a close, and it brings the whole kind of module to a close, really. So it's been a real pleasure to deliver this over the 4 parts. Like I said, if you've missed any of them, all of the recordings are on YouTube, on the Cookson's Consultancy YouTube channel. Get on there, have a watch of them, like them, subscribe to it, do everything like that. Like and subscribe. If you want any other courses, please give us a shout. And if you don't want to do the surveys yourself, after all of this training, if you still think I could still do with somebody on the roof to help me, support me, we do obviously offer full independent survey offerings. We have no affiliations to manufacturers or contractors, so our advice is always non-commercial. We do what's best for your roof. I'll just leave my contact details on the page there. So if you want to get in touch, please do. A couple of questions